All right, so now we have enough information to tell whether a solution is acidic, basic, or neutral, given a variety of different information. So you want to go ahead here, pause the video, and try to work through these on your own and see if you understand this stuff. So hopefully you paused the video, figured it out. Let's go ahead and go through it. So first, in this first scenario, we have a pH of 6. And remember, if the pH is less than 7, that means that the solution is acidic. So in this case, our solution is acidic. That one was very easy. In this case, in the next case, we have a pH of 8. So we remember that pH greater than 7 is basic. And so 7 or 8 is greater than 7. And so this solution is basic. Next up, we have that pOH is equal to 7. And so we remember that 14 is equal to pH plus pOH, or the pKw is equal to 14, which is equal to the sum of pH and pOH. And so if we plug in 7 for pOH, we can solve for pH. And so in this case, pH is equal to 7. And we remember that if pH is equal to 7, then it is a neutral solution. Next up, we have a pOH of 2 here. Again, we remember the same thing as before. pH plus pOH have to sum to be equal to 14. So we can plug in 2 for this pOH. That means that our pH is then 12, right? 12 plus 2 is 14. If your pH is greater than 7, that means that you are basic. So this is a basic solution. Next up, we have the concentration of H plus is 1 times 10 to the negative 8. And so we can take the negative log of this number to get the pH, because remember, pH is equal to negative log of the concentration of H plus. And so if you take the negative log of this, what you'll get is 8, a pH of 8. And so that's greater than 7. And so this solution is basic. And then finally, what we have here is that the concentration of hydroxide is 1 times 10 to the negative 14. And so you can actually do this problem in a number of different ways. You get to the same point. You could say that the concentration of hydroxide times H plus is 1 times 10 to the negative 14, right? And then you could plug this number directly into there, solve for the concentration of H plus, and then see which one's greater, or change the H plus into pH. You could also say that the pH, or that the Kw is equal to 14, which is equal to the concentration of H plus, which is equal to pH plus pOH, right? Then you can convert this to pOH, right? Because pOH is equal to the negative log of hydroxide, which we see that we have up to the negative 4. So that means that the pOH is equal to 4. And so if this number is equal to 4, then your pH has to be equal to 10. And if the pH is 10, that's greater than 7. So overall, that is basic. So you see, when we're talking about the concentration of H plus and the concentration of hydroxide, and we're talking about pH and pOH, they're really the same thing.